Hey guys, this is Scudz from N2KM with my buddy Topher, and this is N2KM Science. Science. It's a pretty broad word. It comes from the Latin scientia, which means knowledge. When pre-Socratic physiologoi began their first inquiries into the natural phenomena around them, it was a huge step in the realm of science. Before that, philosophers were more interested in the supernatural or theological explanations for physical events. Fast forward to the late Middle Ages, and Greek texts flooding into Italy fueled what we now see as the birth of modern science. This was the Renaissance, and it gave us Copernicus, Descartes, Bacon, and Galileo. What it also gave us was the subject of our first video, the microscope. Somewhere, sometime in the foggy days of yore, somebody picked up a clear stone that was fatter in the middle than on the edges, and noticed that it distorted the image coming out the other side. This discovery led to burning glasses, or basically magnifying lenses, that were used to light fires. And all the way back in 212 BC, Aristotle supposedly used one as a weapon against Marcus Marcellus in the siege of Syracuse. And in 25 AD, Pliny the Elder wrote of using crystal balls to light fires on paper. Despite philosophers' fascination with these tools, widespread use of lenses didn't quite start until the late 1200s when glasses were invented. Now, the simplest microscope is just a magnifying lens, a single lens that magnifies through angular means alone. The first simple microscopes weren't very powerful, however they inspired wonder in the people that used them. This prompted those with knowledge of lens crafting to try and get lenses of greater and greater curvature to get bigger and bigger magnifications. However, simple microscopes have their limitations, and what brought about our modern microscopy was the invention of the compound microscope. This is where history gets murky. The use of two or more lenses in an optical device gave rise to both the microscope and the telescope, and was a huge discovery. It was all at the same time that three men claimed that they were the inventors. The first is Zacharias Janssen, a twice-tried coin counterfeiter and spectacle maker. Now, the only evidence of this were his son Johannes' constantly contradicting claims. Sometimes Zach invented multiple lens optics in 1590, or sometimes in 1608. Sometimes he and his son both invented it in 1618, and still other times, Johannes completely lied about his age to possibly ride his father's seemingly imaginary coattails. Another more likely candidate is Hans Lippershey. He was Zacharias' biggest competitor and also next-door neighbor. He also was a spectacle maker, and in 1608 filed a patent for a refracting telescope that used compound lenses. However, the first coining of the word microscope comes a year after Galileo Galilei's invention of the occhialino in 1609. This was a compound microscope made from a convex and a concave lens. However, it would be another 50 or so more years until the microscope truly became a tool for scientists. This can be strictly credited to Antoine van Leeuwenhoek, the father of microbiology. It's funny, because though in the mainstream he's considered an amateur, his experiments were very high quality. His microscopes were the best at the time, and it took another 150 years of optics to duplicate his craft. He made many scopes, of which only 9 survive, the most powerful of which is 275 times magnification. However, records say that he had a scope that could go 500 times, and he was the first to observe protists, bacteria, sperm, skeletal muscle striations, and did extensive research into the coffee bean. Not much happened with microscope technology for the next 100 or so years until Charles A. Spencer came onto the scene in the middle of the 19th century. An American, he founded an industry of previously unimaginably high-quality optics. These scopes that change little to today can get qualities of up to 1250 times with white light and 5000 times magnifications with blue light. It wasn't until the invention of the scanning electron microscope that made greater magnifications possible. Now, the scanning electron microscope, or SEM, was co-invented by Germans Max Knoll and Ernst Ruska in 1931, and then improved upon by Manfred von Ardeen. This was a whole new monster. Instead of using photons passing through or bouncing off a sample, a vacuum was created and electrons were accelerated until their wavelength is 1/100,000th the wavelength of visible light. A stream of these electrons is then shot through the vacuum at the sample, bounce off, and produce an image on an electron-sensitive photographic plate. Using this process, an electron microscope can actually see the diameter of an atom. Now, most SEMs aren't quite this strong, but they can magnify things up to 1,000,000 times, which allows them to see different biological molecules. The only problem is, no living tissue can survive the vacuum, and so anything being scanned under an electron microscope has to be dead. The fastest growing field of microscopy today is scanning acoustic microscopy, or SAM. This uses extremely high frequency sound waves to non-destructively penetrate solid objects and give an image of their internal structure. Now, this was invented in 1973, and to this day, huge strides are being made with the technology. In fact, recently, a new technique was developed to not only detect if a cell has cancer, but what kind of cancer the cell has. Mind-blowing. Back when Greek and Roman philosophers like Aristotle and Pliny were busy trying to create death rays out of crystal balls, I'm pretty sure none of them could have imagined that their works would lead to technology like the light microscope, SEM, and SAM. However, you don't have to just imagine it. A quick Google search will show you that online you can pick up a pretty decent light microscope for around $100. Once you do, you're going to want to start looking at all the cool stuff around you. To do that, you're going to need to learn how to prepare slides. So now, I'm going to show you 2 slide preparation techniques. One for preparing plant cells, and one for animal cells. First, we're going to prepare the onion cell slide. Onions are good to use because they have an easily accessible layer of cells that's only 1 cell thick, and their cells are comparatively large, so they can be easily viewed, even under low power. First, we're going to cut the onion until you have one layer that's about a centimeter square. Next, using your tweezers, look at the inner part of the layer of onion and carefully peel the inside away. And what you should be left with is a tiny film that's 1 cell layer thick. Next, get a slide and place the layer as smoothly as you can onto it. Next, all you have to do is apply a drop of saffron. And it takes a few minutes for the stain to set. That's fine. Then, all you need is a cover slip. Now, the liquid, through adhesion, will keep the cover slip stuck to the slide with no need for glue or anything like that. Now, to apply a cover slip, you want to hold the slip at a 45-degree angle and then drop it down. Now, if there's a little excess stain coming out the sides, you can use a paper towel to dab it up. Viewing stratified squamous epithelium is just as easy. Just take a cotton swab and rub it around the inside of your cheeks. Now, take a slide, apply the swab to the slide in the center. Now, with a drop of methylene blue, stain the cells. Then, apply a cover slip in the same way as the onion cells. Well guys, I hope you enjoyed this video. Please like and subscribe, like our Facebook page, and check out www.n2km.tv. Now, I'm going to leave you with a couple videos of what you can expect to see with your microscope. Stay curious, and thanks for watching.